Okay, measures of dispersion. Measures of dispersion are also known as variation, are statistics that measure the spread of data on the real number line. What do I mean by that? So I'm going to take two cases. Maybe go for three. Okay, so let's take case one, and I am going to, each dot represents an observation, and the more I put observations, it simply means that if I pile on observations, it simply means we have more data points from that interval. So here is one. So those are the data points, and they lie between, say, 4 and 6. Now here is another sample. I'm piling stuff. And that is between 4 and 6. And the last case, I have one observation, let's say 4, and everything happens to be the same 4. So the first case, the spread that we see between 4 and 6 right here is very small. In other words, we have low spread, small variation. In the second case, the spread is significantly large. So higher spread, which would mean large variation. The next one here, we just have one number, and every single observation is the same number, which simply means no spread, no variation. Now, this is the last case is a trivial case in statistics. So it's very trivial. It's unlikely that we would analyze data and end up with an observation or a sample that has the same observation. So it just doesn't happen in statistics. So our goal is to come up with measures that would give us a sense of how the data is spread. Is it spread too much, or is it spread too little, and so forth. So the common measures of spread are range, which is 1, and variance. Last one is the standard deviation. And it is related to the variance. If you take the square root of the variance, you would get the standard deviation. So what is the range? So when I explained variation, I shaded between 4 and 6. And I did the same for a higher spread also. So I pretty much measured the distance between the minimum value and the maximum value of data. So range simply measures or is measured as maximum minus the minimum of the sample. That is the largest value of the sample minus the smallest value of the sample. Variance has a tricky formula. So if we want to find variance, we can use the calculator. Doing it manually is going to take a lot of time. There is another measure of spread, dispersion. It is called the interquartile range. But before we could do that interquartile range, we need to know what quartiles are. And that is in section 3.3 under measures of position. So we've got to wait until we could do interquartile range. So for now, we're just going to stick to variance and standard deviation. And if a problem warrants, we could do range as well. Just like measures of center, where we said the median is better than the mean, here the standard deviation is definitely better than the range in measuring variation. So okay. So here is a sample, a very small sample, and it represents the miles per gallon for a 2013 Ford Fusion for 6 randomly selected vehicles. And we've got to compute the range, the sample variance, and sample standard deviation in miles per gallon. The key words to note here is sample, sample, because there is something else called an estimator for population variance and population standard deviation. When I do it in the calculator, I'll let you know. If we want to find the range, we've got to simply do maximum value minus the minimum value. What is the largest value that we see? It is 37. The smallest that we see is 23.6. If we subtract the two, we will get 13.4. And that is the measure of spread of a variation of 13.4 miles per gallon between or among the 6 randomly selected Ford Fusion vehicles. So going back to the calculator here, I'm just going to enter this simple sample after I clear out my list. I have 34, 33.2, 37, 29.4, 23.6, 25.9. Let's make sure that we entered everything correctly. Yeah? Yes. Second mode to exit, start, go over to calc. So The calculator gives a whole lot of information. Of course, the first one is the mean, and that is 30.52. The second line that you see is the sum of all observations. The third line is the sum of all squared observations. So you take each observation, square it, and then add them. The thing that we want is SX, 5.13. 4, we'll just round it. If we want to do it to 4 decimal places, we'd have 5.1336. And that is the sample standard deviation. The next one that you see, sigma x, is an estimator for population standard deviation. Now, how do we find the variance? We know the sample standard deviation is 5.1336, and variance is simply the square of the standard deviation, because the standard deviation is the square root of the variance. So I guess I'll write it up here. Variance is the square of standard deviation. So 4.686, sorry, 5.1336, and I square it, I get 26.35384. I'll call it as 26.3539, and that simply would be the sample variance. So here we have the pressure that the concrete mix could withstand, and we have a sample of that was assessed over 28 days, and the pressure or the strength of the concrete is measured in PSI, and we have the observations given to us, and they are randomly selected. Of course, we want to find excuse me, we want to find the range and the standard deviation. Specifically, sample standard deviation, so SX. The maximum value here is 4090. The minimum value is 2940. And that is going to give us 1150. To find the standard deviation, we make use of the calculator. So we've got to be careful in entering the numbers in the calculator. If we mess up one single observation, your entire answer could get messed up, or will get messed up, not could. $40.40 and 3780. Let me double check. Okay, so exit. One variable statistics on list 1, and the average happens to be, it's always good to know the average. So the average strength is 3,670 psi. The standard deviation, or the variability, is 459.646. I could round it to 2 decimal places and call it 459.65. Okay, so here we have 2 different classroom types. One is a traditional version, the other is a flipped version. A flipped classroom is where you deliver the content, for example, the lecture at home, and then you come back and do only activities and homework in the classroom. So you have to do all the viewing and reading and understanding on your own at home, and then you come to class and do a discussion. A traditional classroom is simply a traditional lecture. Now, we want to know which sample has more dispersion in the scores using the range, and then using the standard deviation. That would be parts A and B. And part C deals with outliers, and we will do that after we do parts A and B. So we need 2 lists. Going to clear list 1 because I entered data from the previous problem. So going to use list 1 for traditional exam scores: 70.8, 69.1, 79.4, 67.6, 85.3, 78.2, 56.2, 81.3, 80.9, 71.5, 63.7, 69.8, 59.8. Let's double check. Okay, for the flipped classroom, we have similar scores: 76.4, 71.6, 63.4, 72.4, 77.9, 91.8, 78.9, 76.8, 82.1, 70.2, 91.5, 77.8, 76.5. Okay, so second mode to exit. Traditional and flipped. So we saved the traditional data to list 1. So I'm going to do 1 variable starts on list 1. The average happens to be 71.8. The standard deviation is 8.836. I'll just call 8.84. The minimum, you can get the minimum from the calculator also. So the minimum is 56.2. The maximum, if you scroll down, find the maximum to be 85.3. And we can subtract the 2 to find the range. And that would be 29.1. So that's for a traditional class traditional lecture sample. We could do the same for the flipped. So over to calc. My data is in the second list, so 2, enter. The average is 77.48. The standard deviation is 7.85. The minimum, scroll down, 63.4. Maximum, 91.8. The range is simply max minus min. 91.8 minus 63.4, which is 28.1. Oh, sorry, 28.4. Yes. So we found the range, we found the standard deviation. It seems pretty consistent, and it looks like, according to this sample, the flipped classroom has a slightly higher average than the traditional lecture average. Part C is part A, B. Part C would like to know, in the traditional course, if we change the score 59.8 to 598, so we're going to go to list 1 and change the last observation. Uh-oh. I believe I accidentally deleted. So here we go again. Just want to double check if my answers are consistent. Yes, so I'm going to go back and change the data point. 59.8 is now changed to 598. And one variable statistics of the data in list 1, which is the scores for the traditional classroom. So the average simply jumped to 113.215. The standard deviation jumped to 145.88. What happened to the range? The range is simply the max minus min. So in this case, it's 598 minus 56.2. 541.8. That jumped also. But notice the jump in the range is significantly higher than the jump in the standard deviation. Even though the standard deviation indicates that there is variability, there is a significant jump in the range when compared to the standard deviation. So this happened because 598 is an outlier. So the range is tremendously affected by the outlier. The standard deviation will also be affected by an outlier, which we saw in this case, because it jumped from 8.84 to 145.88, but it is just not as bad as the range. But is it wrong? Is it affected by outliers? Yes, but just not as bad as the range. So outliers will definitely affect the range as well as the standard deviation.